Yes. Okay. So my presentation would be about air pollution and how do we solve this in a more global level for air purifying roads, which can be which can be one of the key components of an eco-friendly community. So first off, let's start with the problem, air pollution. Air pollution is a global threat that is significantly hazardous to the ecosystem and human health. It is what the other presentation like discussed earlier, wildfires, fires, or calamities like that are a huge factor of it, but those are like extreme circumstances where that contributes to air pollution. But if we consider it like in our daily life or daily life basis, it is a byproduct of energy use and production, which is by burning a few fossil fuels that releases chemicals into the air. So it's the most simple example of it would be vehicles or automobiles that uses gasolines as fuels. So approximately 7 million worldwide deaths every year are attributed to air pollution according to the World Health Organization. And then it is also considered as of current as a fourth leading early death risk factor, which contributes to like 4.5 million outdoor deaths and also 2.2 million indoor deaths. So what are the effects of air pollution? So we have these compounds or like air pollutants, such as smog and soot, that can irritate the eyes and throat. It can trigger asthma and allergies, penetrate the lungs and bloodstreams, and it can lead to respiratory diseases like bronchitis, which at the most dangerous situation can lead to heart attack and death. Then there's also the most popular one and the most known one to us, which will be the contribution to greenhouse gases leading to global warming. And then there's this air pollutants that exist in the atmosphere, which exist in small amounts, but they can be really dangerous, such as benzene. It is a classified carcinogen that causes eye, skin, and lung irritations and also blood disorders. We also have the dioxin that harms the immune system, nervous system, reproductive and endocrine system in the long run. Then there's also mercury in the air that attacks our nervous system, and like they talked about it earlier in the second to the last presentation would be lead that affects children's IQ and ability to learn in small amounts. But if it's like if they're exposed to it in like large amounts, it can greatly harm their kidneys and brain. Moving on, we have the automobile emissions. So the most prominent automobile emission would be carbon emissions, such as carbon monoxide, which they also talked about earlier. There's also hydrocarbons, nitrogen oxide, volatile organic compounds. So everybody breathes in a small amount of nitrogen oxide from the air, but it can be harmless at first, but exposure to it in the longer run and to larger amounts of it is a huge threat or can damage our respiratory airways. And then these compounds emitted by automobile reacts with sunlight, which is a photochemical reaction, which leads to the formation of nitric acid that contributes to the formation of acid rain, causing structure erosions and is harmful to vegetation. And then there's also the photochemical smog and ozone or tropospherical ozone. It's considered a long-range pollutant that is more harmful to areas distances away from it rather than the origin of the pollution, which is like urbanized areas or roads or areas of high traffic. So here we will see like a diagram of how these reactions happen. So we have the nitrogen dioxide here, which reacts to the UV light or the solar radiation, along with water that forms nitric acid. And then the solar radiation reacts with nitrogen dioxide that forms nitrogen oxide, and then it reacts with the oxygen, and then it forms the tropospheric ozone, and all of this leads to the photochemical smog. I mean, these are like during the mornings. I don't know if you guys see it. I mean, there's a lot of instances already where there's like poor visibility, especially in like cities like San Francisco and stuff, where there's like a lot of cars. Those are mainly caused by photochemical smog, especially if it's not during the morning. And then, we have here illustration of the formation of the tropospheric ozone, a major air and climate pollutant, which causes global warming, or one of the contributors to global warming. And it is a highly reactive oxidant, harmful to vegetation and human health. It is also called, these things are also called secondary pollutant, because they're not emitted directly, but are instead reacting with the original gases or the original pollutants to, like, in the presence of sunlight. So tropospheric ozone, or like O3, are really damaging to, or are really damaging our agricultural industry, because it reduces the plant's capability of photosynthesis or sequestering carbon dioxide, and also it harms their health and reduces their productivity. And it can also lead to chronic diseases, especially for the vulnerable, like the elderly and the children. Moving on, so here we're going to talk about photocatalyst roads. So earlier they talked about catalytic reactors, and right now I'm going to talk about photocatalytic roads. So it is photocatalytic roads are the adding photocatalytic materials into concrete. It is a promising technique that aims to treat pollutants, especially at sites of high-level pollution. This is mainly aimed at urbanized areas, by enabling pollutant degradation from the surroundings and transformation to less harmful products through the action of sunlight. So the addition of photocatalytic compounds to concrete enables products of reactants to be absorbed by the surface and be washed away by precipitation, which I want to talk about later more after I talk about how it works. So this is how it works. Let's see. Let's go to this illustration here. So yeah, this is an illustration of how photocatalytic road works in purifying the air. So photocatalytically active materials like titanium oxide, which is the main component of it, are added to the pavement or road surfaces and building materials, which then reacts with sunlight, resulting to the oxidation and reduction of pollutants due to the presence of photocatalysts and precipitated on the surface, which can be removed through rain or washing afterwards. So after the pollutants have reacted with the photocatalytic sources like titanium oxide, they are then absorbed into the surface, and they can be, they are stored there until they are washed away by water or natural precipitation like rain. And going back, so we have here that the application of titanium oxide leads to the decomposition of organic materials when added in water in the presence of ultraviolet light. It forms anatase. It is an air purifying material which origin is at Japan in 1966 in the form of photoactive crystal. Anatase is actually a widely used air purifying material which It started in Japan, but is now widely or like globally used in many industries. And like anatase coating are added to the pavement to maintain photocatalytic activity, even in the presence of traffic abrasion. So anatase like ensures the durability of the road, that even if like cars skidded through it and whatnot, it won't wear away that easily. Another thing is that the use of titanium, or like just to add for the information, the use of titanium oxide was actually patented by Fujishima and Honda during 1972. They discovered the hydrolysis of water and oxygen and hydrogen in the presence of light by the means of titanium oxide anode in the photochemical cell. So that's what started this whole idea all in all. So the addition of titanium, or like anatase or titanium oxide to the surface leads to transformation of nitrogen oxide to less harmful substances like nitrates, which is then absorbed back to the surface, like what I talked about earlier, due to the alkalinity of the surface. So the reactant gases like nitrogen oxide and nitrogen dioxide are effectively trapped inside the surface with the nitrate salt product of the reaction. Okay, so here's another diagram. It is a more in-depth diagram of how the mechanism of photocatalysis works. So when light energy is irradiated from the sun or other visible light onto the titanium oxide, surfaces coated with it generate strong decomposition, which decomposes and detoxifies pollutants and organic contaminants. So it's not just air pollutants that they become, or like that they decompose, but there's also organic contaminants, which includes microorganisms and viruses, which is kind of interesting that they progressed this far through research. So in here, electrons are released when light energy is irradiated into titanium oxide surface when combined with oxygen, resulting to superoxide anions. The surface then becomes positively charged and takes electrons from moisture in the air. The moisture in the air that has lost electrons becomes hydroxyl radical, which is often called the detergent of the troposphere, because this hydroxyl radical helps a lot in cleaning air pollutants in the atmosphere. And then these hydroxyl radicals then react with pollutants and organic contaminants, decomposing them. The superoxide anions and hydroxyl radicals, through the power of oxidation destruction, decomposes pollutants and organic contaminants, consume or like turning them into water, carbon dioxide, and other harmless substances like nitrates. So going back to earlier, one of the problems they see in this project would be the effectiveness or the efficiency of the road, because what if they absorb more and more of those pollutants into the air, and then over time their efficiency will decrease. But with it can see, because of its properties, it through washing and precipitation, you can just the efficiency can just be restarted and like how it was before, because those are the precipitation washes away the pollutants from the surface. And then here's another interesting application of photocatalysis materials. They have this company called Ecosho2. Ecosho2 is a company that they promotes this revolutionary self-cleaning building coating, which is derived from this photocatalyst materials, mainly titanium oxide, that turns stains and pollutions into harmless byproducts. It's a really interesting product that they have, because so this coating here, it reacts with air pollutants indoors and outdoors, and also organic contaminants. And when the titanium oxide in it, like it works just like how with the road or the photocatalytic road. And then what's more interesting in it is that this, or like what they added in this one, is that this one is the active oxygen species that was acquired from the reaction, decomposes dirt, soot, and other organic contaminants, then oxidizes it into carbon dioxide and water. So it has this self-cleaning property that it never really gets dirty. And then it also has this hydrophilic effect that further contributes to that, that prevents water from like forming water droplets, and instead the water like condenses together and forms this sheet that washes away organic contaminants and makes the coat dry quickly. And it also, because of this hydrophilic effect, it also has this anti-static properties due that so urban or like particles and pollutants are not, or like will not be that much attracted to the coating. And here are my references. So that's it for my presentation. Oh, I'm sorry. I actually have a video to show you guys about the photocatalytic road. I kind of forgot about it the middle way, so I'm gonna play it now. Okay, so that's it for my presentation.